All right, so here we'll be looking at dot product and their properties. So what is a dot product? If you have two vectors u, which is a1, a2, I mean, this is the horizontal component and the vertical component, u, and this is v, b1, b2. So if you find a dot product, all you need to do is to multiply the horizontal component, which is a1, b1, a1, b1, and then add it to what? You just add it to the vertical component, and you're done. So this is how to find the dot product. And one thing here is that if a dot product is not longer a vector, a dot product will give you a real number, right? So take note of that. This term is not a vector. And that is why you can see it's not in terms of a component, right? So another property is that what the dot product of A, the dot product is commutative. I mean, it's just like the normal products we know. So U dot V is the same thing as V dot U. And also here we can apply distributive laws or associative law for multiplication. And here you can see we also have distributive law for vectors. If you have U plus V, everything dot W is the same thing as saying U dot W plus V dot W. And another important property is this one. If you have the square of the magnitude, it's the same thing as the vector dot itself. For example, because you remember if you have U to be AB, we know that the magnitude of U, the square of it, is nothing but the root of what? This is simply root of A squared plus B squared, yes? Which means that the square of the magnitude is just A squared plus B squared. And also, what is U dot U? U dot U simply means AB dot AB, which would just be the product of the horizontal, which is A times A plus B times B. And this is A squared plus B squared as well. So U dot U is the same thing as what? As the magnitude of U squared. Now let's just take this quick example here. It says if the vector, you have vectors, right? You have U is equals to this, and V is this. You want to find U dot V. So what do? Just apply the definition. U dot V is sine 20 cosine 20. You want to multiply with cosine 80 and minus sine 80, right? So just multiply this and this. So you will have sine 20 cosine sine 20 cosine 80, then minus cosine 20 sine 180. Right? So now if you look at this one, this is nothing but what? You can write this as sine 20 cosine 80 minus, this is 80, sorry, 80 here. So you can write this one first because multiplication is commutative. So you can write it as sine 80 or you don't need to rewrite it. I think it's fine. You can use it directly. This is nothing but what? From here, we can just write this as a sine, because this is just going to be sine 20 minus what? Minus 80. And this is sine of what? Minus 60 degree, which is minus sine of 60. And this is minus what? Sine 60 is what? Root 3/2. All right. So now let's discuss angle between what? Angle between vectors. So if you're looking at angle between vectors, you will see something very interesting here. The angle between two non-zero vectors is given by this formula, which is cos theta is equals to u dot v divided by what? The magnitude of u and the magnitude of what? Of v. Okay. So this one, I think, let me just have a small proof for this formula, right? So let me create a space here so that you can see. Now, you know, if we have a vector, let's say you have a vector u, every vector u, let's say it's called AB, right? And any vector v, call it what? C and D. So these are two vectors. But let's say the direction, because every vector has what? Has a direction. Let's say the direction is theta. And let's call the direction of this vector, call it theta 2. So it means that if we look for u dot v, what is u dot v? Okay, so before we do u dot v, if you have a vector u, remember a vector u, you can write a vector u as what? The magnitude of u times cosine of its direction, right? And here is the magnitude of u times the sine of its direction. The direction is theta 1. Also v, we can write v as what? The magnitude of v times what? Cosine of theta 2. Also the magnitude of v sine theta 2. So this is two vectors, u and v. Now, what is u dot v? U dot v, which is the product, the dot product, is just going to be this vector. Remember, this is theta 1. Multiply by which vector? V, which is the magnitude of v cosine theta 2, the magnitude of v sine theta 2. So what can we do here? It means that u dot v is just what? You multiply these two, this and this. So you will have magnitude of u, magnitude of v, cosine theta 1, cosine theta 2. Remember, it's no longer going to be a vector, right? Then you have plus magnitude of u, magnitude of v, sine theta 1, sine theta 2. Because this is what dot product does. Dot product will multiply this and this, and also the vertical component. Now, if you look at this one, what is common? The magnitude of u, magnitude of v is common. So you will have cosine theta 1, cosine theta 2, plus what? Sine theta 1, sine theta 2. And this, if you look carefully, you will see that this is nothing but what? Cosine of theta 1 minus what? Theta 2. Okay. So what is theta 1 minus theta 2? So you see that theta 1 is the direction of what? Vector u. Theta 2 is the direction of what? The vector v. So like now, if you look at this one, so theta 1 minus theta 2 is going to be just what? It's just going to be the angle between u and v. So let me say, this is what we're saying. For example, if this is vector, let's say this is vector u. If this is vector u, remember, this is going to be u. So this is the magnitude of u itself. And this is going to be theta 1, right? Because this is the direction. Remember, the direction always comes from where? It comes from the positive x-axis. So now let's say we have another one here. And let's say this is v, right? If this is vector v, where is theta 2? Because theta 2 is the direction of vector v. So theta 2, remember, it will still start from where? It will start from the positive x-axis up to the terminal. So this is theta 2, right? So you can see the angle between the two vector u and v is nothing but what? But this small angle here, because this is u and this is v. So you see, this is our theta actually. And you can see that the theta here is just going to be theta 2, or you can say theta 2 minus theta 1. It's okay. Remember, cosine is even, so it doesn't matter. So you can say theta is equals to what? Theta 2 minus theta 1. Or you can say theta 1 because cosine is even, so no problem. Yeah. So that is why we will say that u dot v it's simply magnitude of u, magnitude of v, cosine of what? Theta. So this is what we call the dot product. So this is another formula for the dot product. So, and from here you can find cosine theta if you want. Cosine theta from here is just u dot v divided by magnitude of u, magnitude of v. Okay, so let's go back to the formula here. Now we've just proved this formula. So this is a proof of this formula. Let me write it here, proof. But one thing we can see from here is that what? If theta equals to 0, it means if the angle between u and v is equals to 0, our formula would just become that what? U dot v is just going to be the magnitude of u times the magnitude of v, because cosine 0 is going to be 1, right? So what does that mean? It means that the two vectors u and v are parallel and they have the same direction. Also, if u is equals to 180, it means cosine 180, remember, is minus 1. So it means u dot v is going to be minus the magnitude, the product of the magnitude. And what does that mean? It means that u and v are parallel and they have opposite direction. Also here, you have theta. If theta is 90, cosine 90 is 0. So it means that u dot v is going to be 0. Then we say that the two vectors are orthogonal. Example 12. The smallest positive angle between the vector. So we want to find the smallest positive angle between two vectors. So first of all, you can rewrite this vector u. Cosine 90 is what? Is 0. So this is just 0. Sine 90 is 1. So this is just 0, 1. Then if you want to find W, what is W? W is cosine 3 pi by 4, right? Remember cosine 3 pi by 4. This is going to be in which quadrant? In the second quadrant, right? Yeah, so in the second quadrant, it's going to be minus cosine of what? Of pi over 4. Because we are using reference angle. And comma, here, still in the second quadrant, it's just going to be cosine, just going to be sine of pi over 4. And what is this? This is just minus root 2 over 2. And this is root 2 over 2. So these are the two vectors. Now, these are the two vectors. So what can we do here now? All right, so here we will find the formula, remember, cosine theta is u dot v over what? So what is u dot v? Now we'll use w. So it's going to be u dot w, because we don't have v, we have w. U dot w is going to be 0, 1. That's minus root 2, 2. Root 2 over 2, right? The magnitude of u, what is the magnitude of u? The magnitude of u is 1. The magnitude of v is also 1. Because here we will see that the magnitude here is just going to be the square of this, which is 2 over 4 plus 2 over 4, which is square root over 4 over 4, which is 1. Here also the magnitude of u is just 0 squared plus 1 square, which is also 1. So in all of it, we will have cosine theta, it's equals to, now what is the dot product? 0 times this, you will have 0 plus root 2 over 2 all over 1. So cosine theta is just root 2 over 2. Yes, so what does that mean? It means that theta is actually, theta is what? Is cosine inverse, right? Root 2 over 2. And we know how these things work. This will be in which quadrant? Cosine is positive either in the first or in the second quadrant, right? In the first or in the what? In the fourth quadrant. But cosine inverse can only be in the first or in the second quadrant. So it means definitely we are in which quadrant? This is bringing us to 6.5. So we have to take the what? The first quadrant. Now, the first thing we do is we look for what? We look for the reference angle. So what is our reference theta? Our reference theta is just going to be 45. You can call theta star is 45 degrees. But since we are in the first quadrant also, in the first quadrant, it means that theta is going to also be what? Theta star, which is 45 degrees. So the answer is not this one. The answer is 45 degrees. So this is not. Okay, so let's go to the next question. It says we should find the smallest angle. So we're looking for the smallest angle between which vector? Between these two vectors, u plus I. So what is u plus I? U is just 0, 5 plus I. Remember, I is 1, 0. So it means that u plus I is just going to be 1 and what? 1 and 5. Right? Then what is v plus, so from here we can get what is the magnitude, because we will need it. The magnitude of u plus I is just going to be 1 squared plus 5 squared. Am I correct? Yes. So this is going to be 1 plus 25, which is root of 26. Now, what is v plus j? V plus j is minus 2, 2, plus j is what? 0, 1. And that will make this to be minus 2 and 3, right? Because you have minus 2 plus 0, minus 2, 2 plus 1, 3. And then we can also find what is the magnitude, which will be minus 2 squared plus 3 squared. And this should be 4 plus 9. And this is root of 13. Okay. Now, remember, we are looking for the angle between these two vectors. So, and what is that formula? Which is theta is what? Is cosine inverse. You can use this cosine inverse u dot v, right? Over what? The magnitude of u, the magnitude of v. So it's either you use this or you just start with cosine. So cosine theta is equals to what? U dot, but now it's going to be what? U plus I. That's what? V plus j, because these are the two vectors. Now you have to divide by the magnitude of u plus I and the magnitude of v plus j. But so far so good. We have not calculated u plus the dot product. So what is u plus I? Don't forget, u plus I now is vector 1, 5. Then you dot it with which vector? Minus 2 and 3. Then you divide by the magnitude of u plus I is already known, is root of 26. The magnitude of v plus j is root of what? 13. So this is what we have to solve, right? Okay. Create more space. Now, this is going to be 1 times this. This is minus 2 plus what? Plus 5. No, plus 15. I mean, 5 times 3. Here you have root of 16, root of 13. And this will give us what? 13 over root 26, root 13. So now cosine theta is 13 over root of 13 times 2 times root of 13. Because that is what? 26, you can write it as root 13, root 13. And this, you can write it as what? You can split it. This is going to be root 13 times root 2 times root 13, yes? Now, root 13 and root 13 will become 13. So this will be 13 over, everything here will be 13 root of 2. Right? So with this, we can try to finish it up. Let's take this up a little bit. It's too down. Okay. So this means that cosine theta is just 1 over what? 1 over root 2. And now you see that what is theta is going to be cosine inverse of 1 over root 2. So we use what we did before. Cosine is positive in the first or in the fourth quadrant. And cosine inverse is going to be in the first or in the what? In the second quadrant. So which quadrant is common? It's still the first quadrant that is common. So this is just a coincidence. It's not always the case that you have to be in the first quadrant, right? So take note of that. Here we have the first quadrant. And what does that mean? It simply means that what our theta star first is going to be 45 still. And then since you are in the first quadrant, theta is going to be theta star, which is still 45 degrees. Okay. Now let me just explain something quickly here since we don't have that example. Now let's assume that here you have what? Minus. So let's assume that one of these numbers here is minus, and we got cosine theta is equals to minus this. So we still this. So this means that what? Cosine is what? Cosine is a negative, so it's going to be in the second or in the what? Or in the third quadrant, right? This is where cosine is negative. So, but theta is going to be cosine inverse, right? Of this one. And cosine inverse, we know is always in the first or in the second. So in this case, you have to take the second quadrant, right? And you know what to do. So it means your theta star will still be 45, but your theta is going to be 180 minus 45, right? Because we are in the second quadrant. All right, so that is just an extra explanation. Okay, so let's look at okay, so let's just take this one more example, and example 14 says, let U, V be vectors such that U is this. So what is U? U, you can write U as just K and minus 1. And V, we can write V as what? V is going to be the magnitude cosine 3 pi by 4. Also the magnitude sine 3 pi by 4. So V is going to be this one. What is cosine 3 pi by 4? Cosine 3 pi by 4 is going to be a minus because that's in the second quadrant and cosine is negative. So this is just going to be cosine pi by 4. And this is root 3 over 2. And this is just going to be sine pi by 4. Okay. So V is equals to minus root 2 over 2 times 1 over root 2 and root 2 over 2, 1 over root 2. This is minus 1 over 2 and what's and 1 over 2. So that is U and that is V. And here we are told that U and V are what? Perpendicular. So what perpendicular means? Perpendicular simply means that the angle between them is 90, right? Remember, dot product is what? Is magnitude of U, magnitude of V, then cosine of what? Right? So perpendicular means that the theta is equals to 90. So it means that U dot V is just going to be 0, right? Because we know that cosine 90 is 0. So what is u? U is minus half, half. No, this is not u. U is k and minus 1. So k minus 1, that's what? Minus half, half. So this has to be 0. So if you multiply, this will be minus k over 2. Then what's minus 1 over 2 is equals to 0. And this means that minus k over 2 is just equals to what? Half. And from here, you'll get that k has to be minus 1. Right? Or you can just cross multiply if you like. You have minus 2k is equals to 2. So k has to be half. K has to be minus 1. All right, so that will be the end for this video. So here we covered the angle between two vectors as well as dot products. So the next, which will be the last for this series, for this section, we'll be looking at some old exams.